Hello viewers, in this video we will see the solution to week 4 assignment 4 for the course Principles of Communication Systems 1. First question, the modulation technique in the signal x of t is equal to AC1 plus km of t cos 2πfc is. So we know it's a well known, this given equation is an ordinary AM equation, it's a well known equation. So answer is option A. Second one, so they have given in the input output relationship V2 and V1 is given by V2 equal to A1 V1 plus A2 V1 square, where A1 and A2 are known constants, and we are giving input V1 as V1 equal to AC cos 2 pi f ct plus M of t, where we know that M of t is the message signal of bandwidth W and AC cos 2 pi f ct is the carrier wave. The output V2 is then fed to the filter, band pass filter, which is tuned to FC. What is the amplitude sensitivity Ka of the AM signal generated? We will see now. So given signal V1 input is AC cos 2 pi ct plus M of t, and they are given the relationship between V1 and V2 is V2 equal to A1 V1 plus A2 V1 square t V1 square. So now we are substituting V1 in both the terms of equation 1. I have substituted. So this becomes AC cos 2 pi f ct M of t, and this becomes AC cos 2 pi f ct plus M of t whole square. And now I am just multiplying this A1 to both the terms, A1 AC cos 2 pi f ct plus A1 M of t. So for this term, first I will expand this one using A plus B whole square formula, A square plus B square plus 2AB formula. So therefore this becomes AC square cos square 2 pi f c, then this becomes M square t, and this becomes 2AB formula, 2 into AC M of t cos 2 pi f ct. Let me call this as equation 3. And then what I will do here is, so I will retain as it is, I am not going to disturb these two, I am keeping as it is. Now I will multiplying A2 to all these three terms, so A2 is multiplied to all these three terms, and now we will try to recognize the equation for AM. So equation for AM, here it is, you can see in this expression, it is, if you expand this one, it becomes AC cos 2 pi f ct carrier term, and then AC Ka M of t cos 2 pi f ct. So you can see here in this expression we have a carrier AC cos 2 pi f ct. Of course this A1 is constant, and then you look at this expression, this term, it is AC M of t cos 2 pi f ct. So it is a multiplication of message signal and a carrier. So this is a double sideband suppressed carrier term, and 2A2 AC is the constant. So we will consider these two, rearranging this the entire equation 4 and then, or if we pass this V2 to the band pass filter, after filtering what we get is, after rearranging of course, so V2 will be A1 AC 1 plus 2A2 by A1 M of t cos 2 pi f ct. So this is, we know that it is Ka, this is nothing but Ka, so this is Ka. Comparing this equation with this equation, we get Ka is equal to, I have written K here, K is equal to 2A2 by A1, this is Ka. So answer is 2A2 by A1. Third question, the power of the double sideband suppressed carrier signal 4 cos 4 pi t cos 6000 pi t is. So try to find the answer for this one, third one. So the given double sideband suppressed carrier signal is 4. Remember, double sideband suppressed carrier is multiplication of two signal, message signal with the carrier signal. So here this is the given equation. We will use cos A cos B formula. This formula is nothing but 1 by 2 cos of A plus B plus 1 by 2 cos of A minus B. Remember, this is an LSB term and this is the USB term. So now equation 1 can be written according to this one. So here 4 is there, here 1 is there for this. So therefore 4 divided by 2 cos, this becomes 6004 pi t, 4 by 2 cos, subtraction A minus B will be 59996 pi t. So now we know that for any sinusoidal function, even for sine also, So the average power P is AC square by 2, that is peak amplitude square divided by 2. So here in this term the peak amplitude is 4 by 2, here also the peak amplitude is 4 by 2. So therefore what we will do here is, here the peak amplitude is 4 by 2 for both the terms. So because this becomes 2. So now according to this equation, peak amplitude is this one, peak amplitude square divided by 2, peak amplitude square by 2 for both the terms. So we will get now 4 by 2 plus 4 by 2, that is equal to 2 plus 2 equal to 4. That is equal to 4. Fourth question, given the message signal M of t and the carrier frequency Fc, the modulation, they have given the modulation. This is of course a well-known double sideband suppressed carrier. This equation is a double sideband suppressed carrier equation. Fifth one, the frequency response of the Hilbert transformer is, we will see for the fifth one. So for the fifth one, the frequency response of the Hilbert transformer is minus j signum SGNF is a signum function, and the frequency, the phase response of the transfer function of this is the transfer function h of f. So it will be, this is shown as shown in the figure. So now the solution for this is minus j signum function of frequency f. Next question is sixth one, the power of double sideband suppressed carrier signal 2 cos 2 pi t cos 2000 pi t. So this is similar to this one. So we will use the same technique, same method. So refer problem 3, we already solved that one. So we know how to, so this is the peak amplitude, 2 by 2 becomes 1, 2 by 2 becomes 1. So therefore peak amplitude is equal to 1. So peak amplitude square by 2, peak amplitude square by 2, 1 by 2 is equal to 1. The answer is 1. Seventh one, consider a message signal with the spectrum band limited to FM and the carrier frequency Fc. The corresponding single sideband SSB modulated signal with the upper side frequency occupies the spectrum, that we will see now. So seventh one, so this is a typical spectrum of AM. So you can see this is upper sideband, lower sideband, and the central vertical line is a carrier. Similarly this side, upper sideband, lower sideband, and the carrier. Now we have to see the frequency range of only upper sideband. So it starts, so I have marked here. So it's minus Fc minus Fm to minus Fc, and then Fc to Fc plus Fm. So option C. So minus Fc minus Fm to Fc minus Fc, Fc to Fc plus Fm. That we see. So that is option B. Minus Fc minus Fm to minus Fc, then Fc to Fc plus Fm. Option B. Eighth one, consider the message signal. This is our message signal 500 pi t. The SSB modulated signal with LSB corresponding to the frequency Fc 10 kHz is. So eighth one, for the single tone modulation, that is for the given message signal cos 500 t. General, I have written the general spectrum I have drawn here. So this is Fc plus Fm. This is Fc minus Fm. Upper sideband, lower sideband. Again here lower sideband, upper sideband. So what is the frequency of lower sideband? Fc minus Fm. So 1000 they have given, and look at this equation. This is 500 pi t. This is 2 pi ft. So therefore we have to take this frequency as 250. Frequency is 250. So therefore Fm is 250 now. Fm is 250. So 10,000 minus 250 will be 9750. Here it is minus 9750. So now the expression for expression for lower sideband, which is SSB, is cos 2 pi Fc minus Fm. This is lower sideband, Fc minus Fm. So we know what is Fc minus Fm. It is 9750 multiplied by 2 pi. You will get 19,500 pi t. So answer is option B. Ninth one, consider a signal x of t, AC cos 2 pi ft plus k sin 2 pi ft passed through a square law device with the output y of t corresponding to the input y given as. So this is the square law relationship between the output and input. This output y of t is passed through the band pass filter with the center frequency of C. So what is the double sideband suppressed carrier signal generated? We will see now. Ninth one. So this is the given equation s of t. X of t is they have given AC cos 2 pi ft plus k sin 2 pi ft. Then they have given the relationship between x of t and y of t. It is the square relation. Y of t is equal to. Therefore, I am squaring the x of t square of this. Then we will expand this using the formula a plus b whole square equal to a square plus b square plus 2ab. So the first term becomes a square cos square 2 pi f c. Second term becomes k square sin square 2 pi f t, and the third term is 2ab. So 2ac ka cos 2 pi f c t multiplied by sin 2 pi f t. So this last term is the double sideband suppressed carrier term. Remember, any message signal multiplied by a carrier signal is a double sideband suppressed carrier. And what is the carrier frequency here? The carrier frequency it is fc here. Okay. Coming to the remaining point, this for the first term. So first term can be written as, so by using sin square theta formula and cos square theta formula, so you can expand this one. So it becomes ac square by 2 cos 4 pi fc by 2. For this again k square by 2 minus, it is a sign, it is a minus. So k square by 2 cos 4 pi fc. That means in both, this is the carrier frequency is 2 fc. Here also the carrier frequency is 2 fc. And remember, this is the DC, this is the DC, this is the carrier with 2 fc. Again this is the DC because A and K are constant in the sense it is the DC. So this is also DC and this is the carrier with the 2 fc. So band pass filter will reject all these terms and will allow only this term. So therefore, so band pass filter rejects all the DC and the 2 fc terms. It will only allows double sideband term, that is it will allow only this term. So the answer is option B, 2 AC cos 2 pi fct sin 2 pi ft. Product, this is a pure, this is not, this is not, this is not, this is the right answer. 10th one, consider the message signal m of t, again cos 200 pi t. Let the carrier frequency be AC equal to 100 kilohertz. The carrier amplitude is AC equal to 10 with 75% modulation. What is the efficiency of the AM signal? So they have given 75%, modulation index as 75%. Convert that into a mere number, 75 by 100, it becomes 0.75. We already solved this one in the previous assignments. So power efficiency formula is eta equal to mu square divided by mu square plus 2. So mu square, substitute the value, you will get this as 21.95%. Thank you, viewers.